Next, we have Keith here from NIST. And I just want to, one quick remark before I turn the podium over to him. We've been working back since way back in the days of this, 2000 or so. So ISA and NIST have been collaborating and working together in this space for pretty much 20 years. And so NIST, I can't say enough about the quality of the work that they do. It's just top-notch stuff. So if you're not looking at it and using it, you really should. So with that, Keith, take it away.
Well, thank you, Eric. So quick background before I get started. So I've been at NIST for almost 30 years now. When I first started working at NIST, I was doing a lot of work in robotics, in machine tools. So a lot of my expertise and what I was working on was in the control systems of robotics and machine tools. Later in like the mid and late 90s, one of the focus areas that a lot of government was working on was collaborative research and collaborative tools, like how we do collaboration. So what we were doing was working with Sandia National Labs. They had a lot of robots out there. We had some robots in Gaithersburg, Maryland, and we thought it was pretty cool all right, let's run your robots in Sandia from Gaithersburg, and you can run our robots in Gaithersburg from Sandia. And it's like everyone was like, man, this is great. It's like, and one day my group leader came by. It's like, what you doing? It's like, man, I'm running the robots out in Sandia. It's like, man, that's pretty cool. It's like, man, that's freaking awesome. But then we started thinking about what's the cybersecurity ramifications of this, and that started a lot of the discussions at NIST right around around 1999 or so. That started the work that Eric had mentioned around 2000, and there's been a lot of standards and development work since then. So for those of you who aren't familiar with NIST, NIST is part of the Department of Commerce. We're a pretty small agency, but our mission is to essentially develop and promote measurement standards and technology to enhance productivity and trade. Some of the big research areas at NIST are advanced manufacturing and IT and cybersecurity. So the work that we're doing here is really a focus of what NIST sees as a priority research area. It's like, why do we always continue to talk about why we need manufacturing for cybersecurity? So I always like to bring up this slide. Unfortunately, I don't have more recent results. But out of the 16 critical infrastructures in 2016, 63 of the incidents that happened were in the manufacturing sector, and it was more than any other of the critical infrastructures. So there are instances that are happening within manufacturing. And unfortunately, still the biggest threat vector is spear phishing. So it's the human in the loop that lets in an agent into the system that can compromise your system. So we've been working on standards and guidelines for, as Eric said, 20 years, everything from the 62443 standards to we have some standards at NIST, some guidelines, special publication 882. One of the recent publications that we've been working on is what's called a manufacturing profile of cybersecurity framework. So the cybersecurity framework was developed in 2014 as an overarching cybersecurity framework for the 16 critical infrastructures. It was designed, since it is various different critical infrastructures from finance to water to manufacturing, the language is pretty high level. Now, in order to make it specific to a particular sector, you develop what's called a profile. So we worked with industry to develop a manufacturing profile of the cybersecurity framework. And what we're doing right now is, as we're going out and talking to a lot of manufacturers, and Eric said that what we're focusing on now is implementation guidance, because everyone sees that there's a lot of standards, there's a lot of guidelines that are out there, but they want examples as to how to implement that, especially in a manufacturing environment, because a lot of the people that we talk to are concerned not just how to implement this, but how it's going to affect the operation of my system. So what we're doing is taking the manufacturing profile, implementing it in a lab environment that we have at NIST, and then based on that, we can develop implementation guidance that goes out to the manufacturers to use. so they can hopefully implement the manufacturing profile in a manufacturing environment while minimizing any performance impacts to their systems. So here's the lab environment that we have at NIST. We have a small robotics system and an emulated process control system. We can't have the actual whole chemical plant within the lab that we have in NIST. But all the hardware and software is actual control hardware and software. So it's sending out actuator commands to an emulated process, and it's getting back sensor commands from the process. So as far as it's concerned, it's operating a real chemical plant. And this is the environment that we're doing our implementations in. We also are taking, as we're doing these implementations, we're taking tons and tons and tons of measurement data. How's the network being affected by the implementation? How is the process being affected by the implementation? So in order to do this, we had two different use cases that we developed. One, Westman Industry, which is a medium-sized chemical manufacturer, and Alpha Industries, which is a small-sized, essentially small metal component manufacturer. As we were going through these use cases and implementing them within the environment, we pretty much found out that in order to meet the language that's in the manufacturing profile, you either have to develop policy and procedural statements or implement technical capabilities. So what we did is we organized our policy and procedure documents into these 6 different documents. This is just an example of how to do it, but this is the way we decided to do it for these use cases. So we have a cybersecurity program document, a policy document, an operations document, a risk management document, then an incident response plan, and a system recovery plan. So this is where all the policy and procedure statements go for these 2 particular companies, fictional companies that we did. Now, the more interesting part that most people have is, in order to meet the language, we broke it down into 35 technical capabilities. So these are the technical capabilities that you would look for, like in a tool, to implement in your environment to meet the language that's in the manufacturing profile. And then for each of these technical capabilities, what we did is essentially describe what the technical capability is. For this one's hardware inventory management. We describe what the security benefit is of implementing that capability, so you understand why you're doing it. We describe potential system impacts that you should be careful of when you're implementing this capability in the environment, and then map it to the manufacturing profile subcategories. So it shows by implementing this technical capability, these are the manufacturing profile subcategories that you essentially fulfill at least part of or all of by that implementation. This is unreadable for here, but you'll be able to get it when you get the slides. So what this shows is essentially, this is a coverage map. So this shows by implementing all these technical capabilities, all the subcategory requirements that are met. So this is showing by implementing these capabilities, you meet all the technical requirements within the manufacturing profile. So what we wanted to do is develop what's called an implementation guide. So what we did is we took the language that's in the manufacturing profile, took a look at everything that says within the language, and then determined, do we need to develop policy and procedure statements to meet this? Do we need to implement some hardware or technical capabilities to do that? We list this out for every single subcategory line. If it's technical, what we did was take a look at potential tools that are out there that meet the capability. And then what we tried to do for our example implementations is take 1 or 2 of those tools and implement those in the lab. So here's just a quick example. Here's one for grass marlin. So what we do is we provide an architecture map to show where it was implemented within the architecture of the use case. We provide a technical overview of what the tool provides, the technical capabilities provided by the solution. So this is mapping back to those 35 technical capabilities, and then also mapping to the subcategory language that is met by implementing this particular technical solution. We also then provide detailed example installation instructions and configurations as to how it was implemented within our test bed environment. So it's very detailed as to this is how you install it and this is how you configure it. Here's just another example showing backup and replication. So showing where in the environment it was implemented, the technical capabilities, and then the subcategory requirements that are addressed. So one thing that I was concerned about by doing this, so a lot of people have been asking for this. Tell us exactly what we need to do. I had some concern that then people would just take this verbatim and say this is what we're doing. It's not the intent of this. These are examples. They're not recommendations. They're not, don't pick it up and do exactly this. It just gives you an idea of how to go about fulfilling these requirements. We also provide a whole bunch of performance measurements. Like I mentioned, a lot of network performance measurements, a lot of operational performance measurements, and they're all available online to everyone. The people who are mostly interested in this type of data are other researchers. So from these 2 use case implementations, we did a total of 44 cybersecurity tool and technique implementations, over 80 different network device and operational performance impact measurements per implementation. And from that, there's over 125 gigabytes of performance measurement data available to the public. So you can see exactly what happened when we did these implementations. And then there are 12 example policy and procedure documents based on those 2 use cases. So from that is what we just published in September of last year. It's called the Manufacturing Profile Implementation Guide. Because it is very detailed for each use case, they are very large documents. Volume 2 is the use case for the process control system. So that was Westman. And it's 353 pages because it has all the nitty-gritty detail of the implementation and the configuration of all of these tools that went in. The same with volume 3. One thing we're currently doing is updating the manufacturing profile to version 1.1 of the cybersecurity framework. When the manufacturing profile was first developed, it was only 1.0 of the cybersecurity framework was available. 1.1 was finalized in 2018, I believe. So we're going through and updating the manufacturing profile to be consistent with what's in version 1.1 of the cybersecurity framework. A lot of it's around cybersecurity for the supply chain. We also work with what's called the National Cybersecurity Center of Excellence. Our work with NCCOE is what we'll do is we'll take a particular technical capability that someone's interested in, do a more focused project around that capability. So we had a project around behavioral anomaly detection. That's completed, and all the guides are available for that. And we're currently starting a system and data integrity project that will begin probably around spring or so of this year. So real quick, just want to go over some quick things that you can do. I try to do this when I give talks. So I think someone was mentioning, I didn't attend the any of the sessions this morning, but I did hear this. I was passing by. So arguably, probably the biggest threat for most manufacturers right now is still destructive malware, ransomware, essentially. It's nothing new. It's been around for a long time. Everything from, back in 2003, from so big to last year was a big year for ransomware with Norsk Hydro getting hit, Hexion. There's a lot of ransomware last year. So what can we do to try to minimize this? So configuration patch management is a big deal. Adversaries are targeting unpatched systems, so make sure that you keep your PC architecture types of systems, your HMIs, your database servers, up to date. Keep them up to date as much as possible. In 2015, it was reported by ICS CERT that essentially 29% of the incidents would have potentially been mitigated by proper configuration and patch management of the system. Another, I think I heard this as well, application whitelisting. So the control system environment is very conducive to application whitelisting because there's very few pieces of software that should be running on a lot of these systems. So deploy them where you can. Again, in ICS report that 38% of the incidents reported in FY 2015 would potentially have been mitigated by application whitelisting. Some cybersecurity actions, restrict logical access to the network and network activity. So again, this is making sure you have a multi-layered network and have good boundary protection. Boundary protection still shows up as the number one thing that DHS finds when they go in. That's pretty much the number one vulnerability that they typically find. Restrict physical access. As most of you know, if you have physical access to a lot of these environments, you can do whatever an authorized user can do. Protect individual components from exploitation. So here's a couple of quick things that you can do that will greatly minimize your vulnerabilities. Remove default passwords, such as those pre-configured in systems. For your OT devices, if they have a physical run key or a physical key, make sure that it's always in the run position unless it's actively being programmed. That greatly reduces vulnerabilities to things like Trisis. It's very difficult to make modifications to those systems when the key is in the run position. Secure deploy patches, disable unused ports and services. Deploy security solution based on potential impact or consequence. It's not a one-size-fits-all. So all the work that ISA has done, IEC with the 62443 standards, the work that we do at NIST, we have multiple levels of security based on the potential impact to your system if it's compromised, potential consequence. Continuous monitoring, a lot of people don't want to hear this. So security is not a once and done exercise. You have to continually monitor your system, especially have the threats and vulnerabilities change. Has your actual system changed? And that's all I have. I think everyone's getting the copies of these presentations, but if you'd like it ahead of time, you can just send me an email, keith.stouffer@nist.gov, and I'll make sure I get it out to you ahead of time if you're interested.